Hey guys, welcome. Yeah, so at least for now, our third and final example. And so we have to decide using the ratio test if this series here converges or diverges. And a quick reminder of what the ratio test requires of us is taking what's inside of sigma to be a sub n. We have to look at the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. And if that's less than 1, the ratio test says that our series converges absolutely. So let's then look at that limit, which in our case, since we're using k, we'll say as k goes to infinity as opposed to n goes to infinity. Otherwise, instead of a sub n, we're using a sub k, which is right here, which is what's inside of sigma. So a sub k plus 1 then would have to be what's in maroon here. And so I have one fraction divided by another, which is the same as the first fraction times the reciprocal of the second fraction, right? Okay, cool. And then now before we take the limit as k goes to infinity, we have some simplifying that we can do. Specifically, right here, 2 times k plus 1 factorial turns into 2k plus 2 factorial, right? Okay, cool. And then right here in the denominator, we have k plus 1 factorial all squared, and that's k plus 1 factorial times k plus 1 factorial. And then here, k factorial all squared is k factorial times k factorial. And that's all important because in our next step, what we're going to do is we're going to rewrite this maroon 2k plus 2 factorial as 2k plus 2 times 2k plus 1 times 2k factorial. Yeah, that way we'll have a 2k factorial in the numerator here that we can cancel with this 2k factorial in the denominator, right? Okay, cool. And also we're going to write this k plus 1 factorial as k plus 1 times k factorial. And likewise with this k plus 1 factorial, and why we want to do that is pretty clear. So we do all that, and then you see this, and as I said, a 2k factorial here appears in the numerator now, and that's from having to rewrite 2k plus 2 factorial as 2k plus 2 times 2k plus 1 times 2k factorial. And this here then, 2k factorial, we can cancel with this 2k factorial. And then the rewritings of the k plus 1 factorials are going to allow us to cancel this k factorial with that k factorial, and this other k factorial with this other k factorial, right? Okay, cool. So if we do all that, then our expression inside the absolute value is going to simplify to this. But then here, 2k plus 2 is 2 times k plus 1. It's 2 times the quantity k plus 1. And we want to rewrite it this way because we have a k plus 1 in the denominator. And so it's going to be friendly with that if we write 2k plus 2 as 2 times k plus 1. And so then by friendly, I mean they'll cancel, right? They cancel. And so then we just have a 2 left from there. Otherwise, we just have this quotient right here. Yeah, okay. And this 2 here, let's distribute it. And that way we just write one thing in the numerator, and that's 4k plus 2, right? All right. And now when we send k to infinity, it's pretty clear that like adding 2 in the numerator and adding 1 in the denominator is like a negligible contribution for large k, right? So we just have the quotient 4k over k roughly to look at, and then the k's are going to cancel, and so we're just going to get a 4 as a limit of k going to infinity of this quotient, and 4 is not less than 1, right? And therefore this series diverges by the ratio test, because the ratio test requires that we be less than 1, and we get 4, which is greater than 1, and therefore it diverges. Yeah? All right, cool. The next 3 videos I'll make about the ratio test will be for the purpose of finding interval and radius of convergence of power series. So look out for those. But otherwise, I hope you enjoyed this and keep watching. Take care.